Hi, today we're going to go through the PAP paper from 2009 looking at question 2. Okay, so question 2 asks us to sketch the curve y equals x squared plus 4 over x squared for minus 4 less x less 4 and to find the stationary points. Now, when you have a function that is one function added to another, so x, for example, in this case, x plus 4 over x squared, so that's one graph and that's another graph. A nice way to think about sketching what the sum would be to sketch them individually on the same axis and think about adding the points together. So let's do that. Well, over here, let's see if that's in a different colour. So let's sketch our graph y equals x. We know simply enough that is just a straight line through the origin like that. Nothing tricky there. Now what about 4 over x squared? Well, let's think about the positive regions first. At 0, it's going to be undefined, but it's going to be 4 divided by 0, so it's going to be infinity. It's going to be coming down from infinity. It's going to be coming down from up here. And then, well, as x gets very large, it's going to be 4 divided by a very large number, so that's going to go towards 0. So we're going to have a curve like this. So it's going to look something like this. The intersection point not being too relevant right now. And well, we notice it's 4 over x squared. So in fact, because x squared gives you a positive value when you square a negative, it's going to be symmetric about the y-axis. So we have exactly the same shape on the y side, the left-hand side of the y-axis. Okay, well now I was trying to think about what that looks like when you add them together. So if we sketch on our axes, so you have x and we have y. Let's think about it. So down here, we're going to have a very small number from the 4 over x squared contributing to a larger, it's negative, but its magnitude is larger. So we're going to have it being pretty much y equals x down here. And then as this gets closer and closer to 0, it gets larger and larger and larger, so its contribution gets larger. So we're going to actually have this getting smaller and this getting larger. So we're going to deviate away from y equals x and tend towards this curve. So what happens is essentially, say it again, we start at essentially y equals x, and as we get nearer to 0, the 4 over x squared contribution gets larger and larger and larger and larger, and the x contribution gets smaller. So we tend away from y equals x and tend towards y equals 4 over x squared. So if we just sketch in asymptotically the curve, the line y equals x, we'll have it passing almost as y equals x, and then suddenly tending off towards the curve y equals 4 over x squared, like that. So that's if we asymptotically sketched in y is 4 over x squared, it's going to tend towards the curve and never actually touch it. So that's y equals 4 over x squared, and this is y equals x. What about the positive region? Well, think about it again. Here we have the 4 over x squared curve being huge and the y equals x curve being very small. So we're going to have it being essentially y equals 4 over x squared. So again, we'll just dot that in. I wouldn't draw these dotted curves on in the exam, it's just to make it nice to visualize. So here, this region, we're going to have it being essentially 4 over x squared. And then, well, we come down here, and again, 4 over x squared is very small. But now we're going to get the y equals x term being much more contributed. So it's going to be just above it. So we're going to have y equals x, and we're going to add on some smaller and smaller terms. We're going to tend towards y equals x. So it's going to come down like this, and have a stationary point here as it turns minimum, and then tend towards y equals x. So that's our curve. In fact, what we'll do is we'll go over it in red to make it clear. So it comes like this, and then like this. And then we're asked, well, we want to do it in the region of minus 4 to 4. So we need to find the endpoints for a start. So let's do that. So what is it at x equals 4? Well, that means y would equal to 4 plus 4 over 4 squared. 4 over 4, 4 over 16, so that's 4 plus a quarter, so that's 4.25. So we get this point here is x is 4 and y is 4.25. What about the negative? Well, we're going to get y is equal to minus 4 plus minus, for 4 over minus 4 squared, that's still 16, so it's minus 4 plus a quarter, so that's minus 3.75. So that's going to be minus 4 comma 3 minus, minus 3.75. And then we're asked to find the stationary point. Well, we know how to do that. Let's just find the derivative. So dy by dx is equal to derivative of x is 1, derivative of 4 over x squared, that's going to be minus 2 times 4 over x cubed. So when that's 0, we get that 8 over x cubed equals 1, or x cubed equals 8. So the only real solution of that is x equals 2. Subbing that in, x equals 2, we get y equals 2 plus 4 over 2 squared. So that's y equals 2 plus 4 over 4, y equals 2 plus 1, y equals 3. So therefore we're going to have a stationary point at 2, 3. So what we'll do is label that on here, 2, 3. And that's our graph.